Hello there, I hope that I find you well. This is going to be a tutorial on proportion, better known as variation. Okay, so depending on which part of the world that you're staying in, some places it's called proportion, some places it's called variation. Basically, there are three types of proportion or variation, and these are direct, inverse, and joint. Okay, the first one we can look at in direct proportion is linear variation, where y varies directly with x. Okay, and the mathematical lingo that we use to say a variable varies directly with another one is this symbol right there. Okay, so this is an example of direct proportion. Okay, later when we talk about joint proportion, you'll notice that it's a special type of variation in which you can have two variables varying directly with a third variable, the dependent variable, or you can have a dependent variable varying directly inversely with two or at least two different variables. Okay, so let's look at another type of direct proportion. Okay, and this one is called the quadratic. First, let's look at quadratic proportion, where y varies directly with the square of x. Okay, and the graph of quadratic proportion is just a parabola. Okay, and then a dependent variable y can vary with the cube of the independent variable x, and the graph of the variation is something like that. Okay, where y is proportional to x cubed. An example could be x could be the amount of time that you spend studying, and y could be your maths exam mark. Okay, so that's the example of cubic variation. Okay, the next that we look at, okay, is inverse proportion. And in inverse proportion, when one variable goes up, the other one goes down. So in this particular case, when y is decreasing, x is increasing. Okay, and mathematically we express it as y varies with the inverse of 1 over x. Okay, that's what inverse means, it's 1 over x. Okay, if you have any questions on direct proportion, you can hit me up. Okay, and then this is the graph of quadratic inverse proportion. You can see it leans slightly closer to the origin than the one for inverse, where x is to the power 1. So next, let's look at how do we tackle questions. How do we tackle questions? Okay, so these are the steps that you use when you're tackling variation questions. Whatever the question, whatever the type of proportion, this is the method and it will never let you down. Okay, first of all, you decide on the type of proportion, whether it's direct or indirect, linear, quadratic, or cubic. The second step, you write the expression with the proportionality sign. The third step, you make the expression to an equation by using equals and k. Okay, so when you incorporate an equal sign and the constant, you replace the proportionality symbol. Next, you use the numbers they give you to find out the value of k. And finally, you write down the formula that you've managed to determine. And next, you can answer questions. Okay, now we'll look at a few examples on how we can answer variation. Here is example 1. Y is directly proportional to x. Given that y is equal to 12 when x is equal to 4, calculate the value of part A, y when x is equal to 6, part B, x when y is 66. Okay, luckily the question told us it's direct proportion. Okay, so the first thing that you do, okay, the expression says y varies directly with x. So mathematically you write the y, proportionality symbol, and your x. Okay. Next, they told us, remember the steps that we use. We convert the proportionality sign into an equal sign and a constant. Okay. So the next thing you say, when y varies proportionally with x, it implies that y is equal to kx. Okay. Next, we use the number that they gave us, which is when y is 12, x is 4, and we substitute them into the equation that we determined. Okay. And then that will help us to determine the proportionality constant k. So 12 will be equal to 4k, and k will be equal to 3. And now we have the formula that we've determined. Your y will be equal to 3x. Okay. So then you can then use that to solve part B. Find the value of x when y is 66. Come to your expression. Make x the subject. It will be x is equal to y over 3. And you substitute y, and you get your value for x is equal to 22. So that's just an introduction of how we solve variation questions. Okay, here's another example that you can pick for yourself, and you can work through this example. Okay, right, so you can pause the video and work through this example. Because of time, I won't be able to explain through this whole video. Okay, I'll just move on to the next section. Okay, so make sure you follow these answers. If you have any problems, you can hit me up, and then we can discuss example 2. Okay, example 3, talk about inverse proportion. Z is inversely proportional to t. Given that when t is equal to 0.3, the value of z is equal to 16. Find the value of z when t is equal to 0.5. Okay, the question has told us that we're dealing with inverse proportion. Right. So because it's inverse proportion, we know that it will be z varies proportionally with 1 divided by t. Okay, so now we eliminate the proportionality symbol by incorporating an equal sign and a constant, which will go to the top of as the numerator and t remains as the denominator. Okay, next you use the information they gave you in the question. T is equal to 0.3 when z is equal to 16 to find the value of k. And when you determine the value of k, you put it back into this expression. Z is equal to k over t, and then we can use this formula to answer the second part of the question. Okay, so that's just a short question example on how we can deal with inverse variation. I hope it's all making sense. Here is a takeaway example that you can go and work out on your own. Okay, so you're given data y and x, and you're told to describe the variation using the proportionality symbol, and you're told to find the equation connecting the two variables. Okay, so below here you got the solution. Okay, and I hope that you managed to work it out and make sense out of it. So quickly, let's look at the last type of variation, which is partial variation, otherwise known as joint variation. Okay, joint or partial variation is a variation in which the dependent variable is affected by two or more variables. An example is how the interest I on the principal depends on the principal amount P, the rate of interest R, and the time in years T. This can be expressed mathematically as I is proportional to P times R times T. Proportionality constant, where K is the proportionality constant. Okay, so for us to solve this equation, we incorporate the proportionality constant. Okay, we do this by removing the proportionality sign and replace it with an equal sign. Therefore, I will be equal to K times PRT, where K is a constant. Given the initial conditions of I, P, R, and T, We can then calculate the constant k. The above is an example of joint variation since there are at least 3 variables that I depends on. You will encounter several of these types of variation both in the sciences and in economics. Okay, here's an example that you can work out on partial joint variation. It says the interest I on the principal P amount invested varies jointly with P, R, and T, where P is the principal amount in dollars, R is the rate of interest per year, and T is the time in years respectively. Part 1. Write a mathematical expression to illustrate the above relationship. Okay, you'll notice we've already done that. This will be the mathematical expression, and to remove the proportionality symbol, it becomes I is equal to K P R T. Okay, so that will be 1 mark. And make sure your final expression incorporates the equal sign and the K. And then the next part of the question says, given that I is equal to 500 when P is equal to 1000 and R is equal to 10 and T is equal to 5, find the constant of proportionality. Okay, and that will be 2 marks. So you can try and work that out. The constant of proportionality should be 1 over 100. Okay, 1 over 100. So you can use that to get the expression I is equal to PRT over 100. Okay, that will be the mathematical expression required. Okay, and you can use that to calculate T when P is equal to 100, R is equal to 5, and I is equal to 15. What will be required of you be to make T the subject of the formula there. Okay, now that we're done with the tutorial, here is your takeaway. It's a question from a specimen paper, Cambridge 2018. Okay, you can go and work it out. You can pause this video and go and work it out. You can see the total is 1, 2, 3, 4 marks. Okay, and that can spell the difference between an A plus and an A, or C and a D fail. So it says R is directly proportional to the cube of P. When P is equal to 2, R is equal to 24. Find the formula for R in terms of P. That will be 1 mark. And then the next question says find the value of P when R is equal to 192. That's 2 marks. The third part says which of these diagrams below represents the graph of R against P. Okay, I'm sure in the introduction to this video, when we talked about variation, we had one of those graphs. Okay, so after pausing the video and working out for yourselves, make sure you get these as your solutions. Okay, for the first part, the formula will be R is equal to 3P cubed, and that's 1 mark. For the second part, your answer will be P is equal to 4, and for the last part, diagram 2 represents a variation of R against P. This tutorial has been brought to you courtesy of eSchool. I hope that you enjoyed watching it, and I hope that it will make a difference in your studies and goes a long way in helping you understand the concepts of variation. Please like and share this video with as many people as you can. Happy studying.